Have you ever stopped to wonder what your water bottle, the shirt on your back, and the tires on your car all have in common? They seem completely different, right? Well, on a microscopic level, they are all built from the same fundamental idea. They are all polymers. Welcome to our deep dive into the world of engineering chemistry. In this video, we're going to demystify one of the most important materials in modern engineering, polymers. By the end of this short lesson, you will understand, first, what polymers and their building blocks, called monomers, actually are. Second, the crucial concept of functionality and how it determines the type of polymer you get. And finally, you'll see exactly how these concepts apply to the real world, from simple plastics to complex industrial materials. Let's get started. Let's start with the official definition. A polymer is a large molecule, or macromolecule, composed of many repeated subunits. These subunits are called monomers. Okay, that sounds a bit academic, so what does it really mean? Imagine you have a big box of paper clips. Each individual paper clip is like a monomer. It's a simple, single unit. Now, what happens if you start linking those paper clips together, one after another, into a long chain? That chain, that is your polymer. The prefix poly means many, and mono means one. So a polymer is simply many units linked together. It's that intuitive. Let's visualize this. On screen, you see these individual molecules. These are our monomers. Now watch what happens when a chemical reaction called polymerization starts. See that? The monomers bond together to form a long, repeating chain. This single chain is the fundamental structure of a simple polymer like polyethylene, which is used to make plastic bags. So where do we see this? Everywhere. The plastic in your laptop casing is a polymer. The synthetic fibers in your clothes like nylon or polyester are polymers. The rubber in your shoes, you guessed it, also a polymer. They are the workhorses of the material world. Now, a simple chain is great, but what if we want to build something stronger or more flexible? To do that, we need to understand a critical property of our monomers. This property is called functionality. Formally, the functionality of a monomer is the number of bonding sites it has. In other words, it's the number of places on the molecule that can form a connection with other monomers. Let's go back to our paperclip analogy. A standard paperclip has two ends where you can attach another clip, right? One at the front and one at the back. So we can say its functionality is 2. With a functionality of 2, you can only make a long single chain. But what if we had a special paperclip, one with an extra hook welded onto its side? This special clip would have 3 connection points. Its functionality would be 3. What kind of structure could you build now? You could still build a chain, but now you could also start a new chain branching off from the middle. Let's see this in action. When our monomer functionality is 2, we get these long, unbranched chains called linear polymers. But when the functionality is greater than 2, we can create branched polymers or even complex 3-dimensional networks called cross-linked polymers. These networks are often much stronger and more rigid. This concept is critical in engineering. A monomer like ethylene has a functionality of 2. It forms polyethylene, a linear polymer, which is flexible and melts easily. That's why we use it for plastic bags and food wrap. We call these thermoplastics. However, a monomer used to make Bakelite, an early plastic, has a functionality of 3. It forms a highly cross-linked polymer that is hard, rigid, and heat-resistant. It was used for old telephone casings and electrical switches. We call these thermosetting plastics. The functionality of the monomer directly dictates the properties of the final material. All right, Let's test your understanding with a quick problem. Let's think this through, step by step. Step 1. Identify the functionality. The problem states the functionality is 2. Step 2. Recall what a functionality of 2 means. It means each monomer has only 2 connection points, just like our standard paperclip. Step 3. Visualize the structure. With only 2 connection points, the monomers to only link up end to end. This means they will form a long, unbranched chain. Step 4. Name the structure and its class. A long, unbranched chain is called a linear polymer, and linear polymers that soften on heating are known as thermoplastics. See? By understanding functionality, you can predict the polymer structure and properties. So let's do a quick recap. 1. A polymer is a long chain made of repeating units called monomers, just like a chain of paper clips. 2. Functionality is the number of connection points a monomer has. A functionality of 2 creates simple linear chains, while a functionality greater than 2 allows for branching and cross-linking. And 3. This simple concept determines whether you get a flexible plastic bag or a hard, rigid electrical switch. Understanding polymers is fundamental to material science and engineering. It's the science behind so many things we use every single day. If you found this explanation helpful, please hit the like button and subscribe for more simplified engineering concepts. Have a question? Drop it in the comments below. Thanks for watching, and we'll see you in the next one.